Science involved. The branch of science that we will be talking about is thermochemistry. Thermochemistry is the branch of chemistry that has to do with heat involved in a chemical reaction. Specifically, we will be looking at potential energy. Potential energy is stored energy that can exert work. Energy can be transferred through work or heat. We also have to consider the first law of thermodynamics, also known as the law of conservation of energy, which states that energy can neither be created nor destroyed. Energy can only be transferred or changed from one form to another. To describe the amount of energy in food, we use the unit of the dietary calorie, which is actually 1 kilocalorie. Just 1 calorie is 4.184 joules. When we consider energy stored in food, we look at the macronutrients. Macronutrients include carbohydrates, proteins, and fats. Before we move on, let's look at the scientific development/history of potential energy.
William Rankine and Rudolf Clausius are some founding contributors to thermodynamics. Rankine, a Scottish engineer and physicist, developed a complete theory for the steam engine, which was later applied to many other aspects of society. He was also the first to make a distinction between potential energy and kinetic energy. Both Rankine and Clausius approached thermodynamics with the theory that one type of energy transformed into another. However, Clausius considered the process to be cyclic, and Rankine focused on the change from kinetic to potential energy. Other founders of thermodynamics include Sadi Carnot, Émile Clapeyron, Robert Mayer, James Joule, William Thomas, Peter Tate, James Maxwell, Willard Gibbs, Ludwig von Boltzmann, and Max Planck. Some others that followed in the 20th century were Albert Einstein, Gilbert Lewis, and Edward Guggenheim.
Science explained. We convert food into energy through a chemical process called aerobic respiration. It is a combustion reaction and is exothermic. We can find out how much energy is in our food through simple stoichiometry. But how do we store energy? Chemical energy, which is a kind of potential energy, is stored in the molecular bonds. It is potential energy because of the position of the particles in the molecular bonds. We store our energy in the ATP molecule. Energy is stored in the form of high-energy phosphate bonds that joins the terminal phosphate group to the rest of the molecule. The energy stored in an ATP molecule is released when the terminal phosphate bond is broken. Significance to society. Pros. With our knowledge of potential energy, we can monitor energy taken in through the food that we eat. Companies who have an understanding of the energy that is found in our food, such as Weight Watchers, can design a program that uses a restricted calorie diet and the promotion of physical activity to help their client lose weight or maintain a better diet. Besides being able to create a better diet, we can use our knowledge of energy to create new environmental-friendly energy technology. These technologies include renewable energy. Renewable energy includes solar power, wind power, hydroelectricity, and more. An example, a company called Agilix is working on technology that could turn plastic trash into synthetic crude oil. Cons. By being able to control the energy in our food and drink, energy drinks have become popular in our market. Energy drinks contain caffeine at levels that can cause headache, insomnia, nervousness, and rapid heartbeat. The more serious side effects include vomiting, seizures, disrupted sleep patterns, and increased blood pressure. The added sugar in these energy drinks adds extra calories, which puts the consumer of the drink at risk for obesity. However, these drinks can still be consumed safely at the amount suggested. While there are healthy weight loss diets, there are also unhealthy weight loss diets. These unhealthy diets that promote weight loss in a short amount of time typically include diets that severely limit calories or restrict food groups that include important nutrients, making the diet unsubstantial and making the consumer insufficient. Barriers to research.
GMOs, or genetically modified foods, are a relatively new method of producing food. We have already seen some repercussions on human health. For example, there is antibiotic resistance, increased allergies, and decreased nutritional value because of GMOs. But there is not enough evidence to show how it affects the amount of energy that humans intake when consuming these foods. Genetically modified foods change the potential energy. It is difficult to monitor what we are putting into our bodies if we do not know how much energy is contained in the food product. When considering renewable energy, we can see that there are barriers to how much we can rely on it. It is not completely developed and is not on a large enough scale to compete with major energy supplying companies. It is also more expensive to use renewable energy, and it cannot fully cover the amount of energy needed to run society. Some other relevant topics include fuel energy, natural gas, a fossil fuel. CH4 plus 2O2 yields CO2 plus 2H2O, with a change of enthalpy of negative 802 kilojoules per mole. Ethanol, a renewable fuel. C2H5OH plus 3O2 yields 2CO2 plus 3H2O. The energy for that reaction is 30 kilojoules per gram. Another example of fuel energy is hydrogen. The equation for hydrogen is 2H2 plus O2 yields H2O, with a change in energy of 140 kilojoules per gram. Batteries are galvanic cells, which are made up of an anode and a cathode. Energy moves from the anode to the cathode, and from that we can calculate the potential energy in volts. Solar cells store energy in two ways. One way is through the use of a battery, where energy is stored as electrical potential. Another way that they store energy is through supercapacitors, where energy is stored in an electric field due to the spatial separation of positive and negative charges. Wind turbines. Many people are beginning to use batteries to store energy from wind turbines for later use. For nuclear reactors, energy is stored in pools of water.
Personal opinion.
Measuring the potential energy of foods is beneficial to society because it helps people monitor how much energy they are putting into their bodies. Also, the ability to measure potential energy offers us the ability to look for other potential sources of energy. Spending time to learn how different organisms, like plants or other things that we use in daily life, is crucial for the development of a thorough understanding of our world. Also, we are able to fully utilize and be more efficient with how we extract energy. In terms of food, we are able to be more economical with how we energize depending on what we are doing. For example, when someone is preparing for a long run or marathon, they eat carbs the night before. For a quick boost of energy, many eat a piece of dark chocolate.